So, everyone, hello. We are back. So, welcome to yet another stream about the Voron V0 build tonight, Saturday evening. Unusual location, unusual time for this, but I happen to have some time this weekend for this kind of stuff, and I want to get done with this printer build as soon as possible, pushing really forward to making this work. So, usual suspects slowly coming in. Alexander, hello. Hello to them, Carmen. This time earlier. GeForces, hi. So, exactly the usual suspects. You have been following this for a while, I guess. I would like to recap quickly where we have left yesterday and what I've done so far. I've done a couple of things so we speed up. First of all, I have installed Raspberry Pi OS and pre-configured Clipper on mainsail, so we can get started compiling the firmware for the Pico board, and eventually we might have to also reinstall Clipper on the Pico Billicle. This is the Pico Billicle board here. If you want to see it, this is how it will look like finally. Here's the plugs to connect our Toolhead cable. That's going to connect the Toolhead and all the electronics to the Pico Billicle. So there's going to be only a short cable going here between these two PCBs. I also connected the power to the Pico Billicle, and I also prepared that we can eventually power the Raspberry Pi from 5 volt on the Pico Billicle, but we're not yet doing this. I'm still powering the Raspberry Pi with an external power supply for the software installation. Then we have 2 USB cables. One USB cable goes from the Pico Billicle to the Raspberry Pi, and the second USB cable comes from the BigTreeTech Pico, goes to the Raspberry Pi, because they're all using Clipper. So here we have Clipper running on this board, we have Clipper running later on this board, and we will also finally have Clipper running on the display. So all of these 3 external devices will have Clipper installed, and then the Raspberry Pi together with Moonraker mainsail, it's gonna connect to all of these different Clipper boards and drive their individual functionality, and that's going to be configured in the software later. Now, what else? I think, one thing that I forgot yesterday, or I realized this morning, is that we mistakenly have attached the Toolhead fan here and the PCB fan. They are identical, but they don't have the same cable length. So I realized that while I was trying to figure out, can I connect this fan to the Pico board, and it was just too short. And then I saw there is a little label here which says PCB fan. So I disassembled the hot end. I mean, not really disassembled. I took it off, switched the fans, and now we have the correct fan here with the longer cable, and the shorter cable, and the fan with a shorter cable is now on the Toolhead. That was, that was a little bit unfortunate that was an oversight. But now I think like back to where we left, more or less. And in the construction and the build manual, it is, we are supposed to be here. So this is state of where we are. We have the power cable coming from the main from the power supply going into the picobellical PCB. We also have the 5-volt cable going out here to the Raspberry Pi, and we also have the E-stepper driver connector cable going into this board, and that's where. And then I mounted it to the printer frame, so it's now screwed firmly on the printer frame, so nothing can basically move anymore, and it's in its final place. Next up, we're going to check. This is a little bit. This is actually a bit weird because I had initially, especially for the RGB connector, I think if we go up a couple of pages, yesterday I was on the Big Tree Tech website, and it was showing that the RGB cable is actually supposed to be down here. And now I was looking again at this description, and it says the RGB connector is actually this one in the middle and not that one down here. But if we look at the Big Tree Tech BTT Pico pinout, I think this was it this drawing? I think it's this drawing here. This drawing here somewhere. Yeah, I think it's this drawing. Yeah, now it's labeled differently. I think that was I looked it up yesterday somewhere, and it wasn't labeled. It was just not labeled correctly, seems like. So we have to move that plug over, and we're gonna connect it to the correct one. So the front LED is actually the middle connector. Now I also have to check whether I did the correct cables. And we'll see that here. So we have black, white, and red top to bottom, which is correct. And we have to continue. Yeah, we can finally, we will definitely power the Raspberry Pi from the picobellical. And that's where we are. Now we have USB cables. We have 2 USB cables. We don't want to connect all of them right now. Starting a fan club. Yeah. So I'm not connecting both USB cables at the same time, because you will see that in a moment, because it's easier to identify the USB serials. So every USB device has a serial number, and it's easier to plug them in one by one and then write down, copy paste the serial numbers, so you know what PCB has which Clipper serial number in the end. But you know from this drawing we have 2 USB cables going to the Raspberry Pi, and we have a different Raspberry Pi. It looks different. It's the this is the, I think it's the 2W with an extension board, and we have the normal 3B+. So all of that is connected already. The 24-volt fan for the Raspberry Pi cooling the electronics is already here. It's installed and connected. We will still have to do some, I think I want to have some cooling for my Raspberry Pi. So I found yesterday or this morning, I found these. I got a couple of cooling blocks still. So some heat sinks here, and I want to do mainly the CPU. So I want to have one on the CPU, and I guess we want to have a smaller one, or the middle-sized. Not sure if we need one here. But this is the USB. This is the USB hub, if you want to call it like that. And memory, I think that's the only CPU, and we have the memory chip here. Or not sure on the 3B Plus what that is, but we can probably put one of these. These are the very small ones actually for the Raspberry Pi 4. They're quite small. I think we can use one of the bigger ones here. The Raspberry Pi 4 has a little bit different shape of these chips here. The chip layout is slightly different, and the size of the chips is different, but still we can use these heat sinks. I think they are good. Just want to make sure that when this thing goes printing and we have a lot of things going on, that we're not overloading, not overheating. So I will just have this heatsink here, and we're gonna have the bigger one for the CPU. And then we should be quite safe. We'll probably also need, I'm wondering if we need a cooling block here, some heatsink for the Pico board. We could probably do this. This is just a Raspberry Pi 2040. I think it's not generating that much heat, but it could be useful. Later in Clipper, we will see in Mainsail OS, we will see the temperatures. And that should hopefully tell us a little bit more about how much heat is actually coming from this chip. Here, I have never tested this, but I think we have one specific heatsink left that's still in the electronics box from this kit for the Pico. So let's do that later. Then we should be fine in terms of the heat sinks. Great. Would a 120mm fan be bigger than the printer? Yes, probably yes. You could probably have a back panel 120mm, but I can show you how big that would be. It's ridiculous. And this is let me show you. We have two different fans here. This is I think this is 120 already. So you could have a new panel printed for the backside. So you could print a completely new panel that's just there for holding this fan. But you could also go with a 150. Right? It completely covers everything. This is one single fan from another computer. Why not? Yeah, I mean, this little fan here is probably not very effective, but it's better than nothing. We'll see, because this is all covered up and we have a little bit of air inlet here, so we're going to push a little bit of air at least through this case. But yeah, it's probably it's not the best solution. Nothing will overheat, yeah, exactly. 150. I see, Porphyrius, I saw that you're going live. I think you're still playing World of Warcraft. I wish you a lot of viewers. I hope people will come to your stream. Okay, so that's done. Next, so this is the situation now. Should all be good, except that we don't connect all of the USB cables. Filament sensor cable is still to do. That's still to do. Filament sensor will be connected to the second middle connector, like that. So we will do this right now. And this is the plug. And we just have to figure out where we are going to put the cable so it's not colliding. I still have this pretty long USB cable here. That's a little bit, we probably cannot put it in the channel. There's not enough space. I will most likely have that connector down here. And we will use a zip tie in the end so we can clean it, have it stored in a clean way, but I don't want this cable to run in front of this fan, because that would eventually be the case. We can try to put it underneath the first USB cable. That could work. Yeah, maybe we start like that, go under this cable, so we have something pushing the cable down. So now it is not going to get in the way, and then we can run it in the channel one back and forth, and then we have just enough to connect. Okay, so the plug is in. Still, I mean, this is getting quite full here. So we have now lots of cables in this channel. I just think we have everything now. There should nothing be added. This must be the last cable. So the only thing that we could maybe connect is the camera. And yeah, this is exactly the case. We have the last cable is in. Technically, we can close this channel now. So let's do that. So nothing has a chance to escape. Looks pretty clean. So yeah, we have this USB cable left here. This is the power cable for the Raspberry Pi. We'll do that once we have done all of the programming stuff and the flashing. We don't want to power up the printer yet. We're just gonna flash Clipper firmware to all of the devices first, and then we'll see. The software setup is like this. We have, let me start terminal. So let's do this. I will show you the terminal when we're gonna increase the font size. If I know how to do this. Let me see. Settings. Default. As the font sizes, appearance, color scheme, font face, font size. Probably let's use 20 or something for the stream. Come on. This looks, I think this is much more readable now for you. Okay, so we are going to connect to our Raspberry Pi. So what I did already, I pre-installed Clipper with the Kiau tool. So that's a helper tool. Once you have the basic operation system installed, that's very straightforward. You just flash it to the SD card. Ideally, you already set your network parameters, so wireless connection and username and password. And you also need to enable SSH, so we can remote shell into the system. And then you download the KiaU tool, which is essentially just one script, a shell script. And once you launch that on the machine, that's on the Raspberry Pi, you can start installing stuff. So installed is already Clipper, Moonraker, Mainsail, and Crow's Nest. So these are the basics programs. So yeah, Moonraker and Mainsail are basically the front end API and the front end GUI. Crow's Nest is an additional add-on that can eventually be used to run a camera. We don't connect a camera yet, but at least we have the software already in place. So we can either later configure a Raspberry Pi camera or a USB camera, whatever works better. The other things, we don't yet need to do anything. I don't want to install anything from this list here, but that's how it's done. So you just use KiaU and run all of the scripts. Basically, just you select the menu items, say install this, install that, and then it's doing all of the magic. That's not a Benchy Tech Pi. It's a Raspberry Pi. In this case, we're using a Raspberry Pi 3B Plus that I just did have. The Benchy Tech Pi has Wi-Fi, and there's yesterday, I guess, or was it today? Today, Benchy Tech launched their Benchy Tech Pi 2. So the Benchy Tech Pi 1.2, that's the one that we have on the V100. And I have it on other printers as well that run Clipper. That works totally fine. It has 1 GB of RAM. For Clipper, it's totally enough. And today, I guess it was, Benchy Tech released their Benchy Tech Pi 2, which is an upgraded version with a little bit faster processor and 2 GB of RAM. That was just announced today. So eventually, I'm probably gonna test it out. But honestly, I think since the 1.2 now is gonna get a price drop, I would still recommend the 1.2 for most stuff. Clipper it's totally fine. It works. So you don't have to upgrade. Honestly, it's not necessary unless you want to run different things on it. Maybe you want to run a little NAS storage, or you want to do a web server or something like that. Yeah, and totally true. One of the major things that I love a lot about the Benchy Tech Pi is the fact that it has a couple of interesting ports that the normal Raspberry Pi doesn't have. For example, it has a 12 to 24 volt. I think it's even 5 to 24 volt. I'm not 100% sure. Yeah, I think it's 12 to 24 volt terminal input. So you can just get power in here without a USB cable. Then it has what's the other connector that was unique for this? Let me see. Yeah, it has a CAN bus interface. So if you are running a Clipper and you're running a Voron printer with a CAN bus, you can directly connect your CAN interface here. So you don't need an additional board for that. So it has a couple of things that are more specific for 3D printers. However, it's a different layout. So if you know the Raspberry Pi layout, this is on the other side and it's swapped, and a couple of other ports are differently located. So it's not 101 a Raspberry Pi layout. So if you have a case, for example, for a Raspberry Pi, that doesn't fit. So you have to have a specific case. It also has an IR receiver, and I think it's even an IR blaster. It's not only one way. I'm not sure. It could be only a receiver. I'm not sure, but it has this IR thingy here. So maybe you can use it to run a multimedia station with it. That might be the case if you want to run multimedia stuff and stream videos to your TV set. Maybe the Benchy Tech Pi now is a worthy upgrade for those people. Now coming back to what we want to do. Yeah, I've shown you this. Now we'll switch over to mainsail OS. Let's go. So mainsail is installed. We can from this point, we can already see all of the config files. Nothing is yet configured here. We can see that we can see nothing. Okay, let's move it. So also a zoom. Let's zoom in a little bit. So here you go. So this is the config files section. And that's it. So you see still not, it's not connecting yet. It is still reporting an issue. I guess what we need to do now is do all of the software flashing first. Then we can configure that we can connect at least the BigTreeTech Pi, the BigTreeTech the Pico, which is the where the drivers are, and then also the Pico Billicle. So let's start with configuring and flashing Clipper to the BigTreeTech Pico using the manual. I've done this already on a couple occasions for the BigTreeTech Pi, but the whole process is very much the same. So we did the Raspberry Pi OS setup, and Clipper and web interface are also installed. Now we need this manual how to install the Pico Clipper firmware. First step here is to configure the chip correctly. And basically just the screenshot here, you need to set everything to the same settings. How that works is on our Raspberry Pi, we'll find a Clipper directory and we can say make menu config. In this menu config, we need to set the Raspberry Pi RP2040 architecture, but that's not for the Raspberry Pi 3B Plus, where we have our mainsail. It's the Raspberry Pi 2040 chip on the BigTreeTech Pico controller board, right? So not mistake that. We're not compiling software for the Raspberry Pi where we have all of the major software running. So RP2040 is the architecture. What else do we need to do? Flash chip. Yeah, that's the same. Communication via USB. And I think nothing else needs to be done. And we are going to save. Now what we do is we build the software. That's the Raspberry Pi software. And that might take a little bit of time. Or we probably should say make clean first. So, and then we need to configure the jumpers. That's also in the manual. So we need to do some jumpers. So the Raspberry Pi, the SKR Pico will actually accept our software. First of all, there is a pin, or there's a little jumper on this board that opens the boot flash, or the boot loader, so we can actually flash something. That's this jumper here. If that is not installed, we cannot flash firmware. And then the second jumper is USB power. So there's two choices how to power up the SKR Pico. You can either power it over USB, when this cable delivers power, then we could use that power. Second option is to power it from this terminal, but you cannot use both power options. Powering from USB is only recommended if you have nothing attached or if you're not running the motors, so that doesn't work. So we will need USB power now. So let me see. I think there is a couple of options how to do this. Yeah, I want to use the USB method. Okay, so what we need to do is we need to install this power jumper so we get power from Raspberry Pi. Now you see the LED is red, and we can push the reset button now. So it's gonna restart. And on the Raspberry Pi itself, on our main computer, so to say, we can check whether we find this USB device now. Probably need to do it as root. Why? Cannot access dev serial by ID. Maybe it's not yet connected, is it? We need to unplug it maybe. Let's do an unplug, plug, restart this thing. So we have the right jumpers installed. Should. Let's see, ls USB. Here we go. So we get this Raspberry Pi RP2 boot. That's a device that we see now on the USB. Then we should see dev SD. Hey, that's a drive. So what happens there is Raspberry Pi, when we have this jumper installed, the Raspberry Pi shows us a virtual drive. Now we can copy the firmware to this drive. We can just mount this drive, mount dev SDA1 mount, yeah, sudo. And that means we are basically just making this accessible. When I go to MNT, we see this is actually a directory. So in our clipper directory, we will have an out directory. And in the out directory, this is the output from the make command. We should have a file that's called clipper.uf2. And that's right here. And that is the firmware file that we need to copy. So simply what we'll do now is we'll copy clipper out clipper uf2 to the mount directory. That's the drive. Sudo, so drive is the file is copied. Now to flash it, we just unmount the drive. And that should already be enough. And with that, we are removing the boot jumper. I'm just doing that, and we're hitting the reset button. And now the Pi should come up with Clipper. So let's see if we find the device. Here we go, Open Moco Inc. Now we have it's showing up as a different device. It's not a drive anymore. Now it should just be this generic device. So we can now dev serial by ID. And that's our clipper serial number. Now, what I'm going to do, since I now know this is my Raspberry Pi, the SKR Pico, I will copy paste this to a notepad. And yeah, we can just, why is it notepad XE? Just use my normal notepad. So my notepad, close off these log files, don't save. And we'll paste this serial number in. This is our SKR Pico. So we need that later. We need to use that serial number in our config file later. Now the second serial number will be from the Pico Billicle. So we do this very same thing. From the Pico Billicle, we know that the serial number, or it should already have Clipper installed. So I'm just going to disconnect the BigTreeTech Pi. So we have not anything confusing showing up, nothing showing up twice. And let's connect this USB cable. And we'll also leave it. Not sure if this can be powered over USB. That's the question we need to double check if this can now get power from USB or not. This could be an issue. Maybe we also need a jumper for that. So let's see the LDO Pico Billicle power USB. Not sure if that is there a special jumper required. Make sure the USB power pins are shortened with a jumper on the frame PCB. This allows the MCU on this PCB to power it from the USB port. Let's see. There is similar steps are now required to flash Clipper to this board. Just trying to figure out how to get it into flashing mode. So we have same configuration. So it's the same architecture, it's the same chip. So communication is also USB, so it should be identical. However, we need to figure out what are the jumper wires or the jumpers that we need to use to set it into USB mode. Let me see where the jumpers are. I think there is one jumper here. That is this jumper next to the USB. Hopefully I can put the jumper on. Is it possible? Yes. Okay, so we have power. We have power. The Pico Billicle is lighting up. So let's see LS-USB, what we see. We have an open MOCO, so that means we should have Clipper already on that device. It has a serial number also. That's the second serial number. Now we could just go and say probably this firmware is up to date. We could also just go. No, Bigtree Tech Pi 5 doesn't exist. I'm using a Raspberry Pi 3B Plus for running Mainsail OS, and I'm using the SKR Pico that is for running the motors, and the Pico Bilical is for this like Toolhead cabling. But the Pico Bilical and the SKR Pico have a Raspberry Pi 2040 chip. So that's where all of the Raspberry Pi naming comes from. But it's not a Bigtree Tech Pi or something. It's a Raspberry Pi chip on the SKR Pico board. But the main controller or the software runs on an original Raspberry Pi 3B Plus. We can show and explain that in a bit again. So we are now driving power to the Pico Bilical from the USB. I think what we need, I just want to be sure that we have the latest Clipper firmware installed. Let's just do it like the manual says. Press down the boot cell and reset button. So there's two tiny buttons, boot cell, reset. So it should now have been reset into this, oh, keep it here. It has probably showing up as a boot device. Nice. Now we can mount dev sta1 to this mount directory, again as a super user. Now, since this is the exact same firmware, there's no difference in the firmware that we're going to install on the Pico Bilical and the SKR Pico, which sounds crazy, but it's Clipper. Clipper is the kernel, if you will, this little piece of software that's called Clipper that runs on these boards. Is by itself is always like the functionality of that is always the same. It just has a specific processor architecture that it's compiled for. But without any configuration around it, it's just a dump piece of software. It doesn't do anything, so to say. It just needs this configuration file to understand what is the peripherals on this chip, what is connected to this Clipper firmware, so to say, what are the other things around, the GPIO pins and stuff. So that's why we can install the same firmware on the SKR Pico and the Pico Bilical, and even we will install this very same firmware here. We are going to compile it for a different processor architecture, but still it is the same Clipper software that's going to be running on this screen. There's just going to be a different configuration file that's going to tell this little piece of software what are the GPIO pins and what are they for. That's the only difference. Sounds like magic. It's a completely different approach than Marlin firmware. Marlin firmware needs to be configured and compiled for the very specific purpose. So if we change one thing, you need to compile this whole thing again. Clipper doesn't need to be recompiled if you attach a new device or if you want to reconfigure something. It just needs to be for the right processor architecture, and that's it. So what we're going to do, we're going to copy the same file because it's the same processor architecture, right? It's also the same chip. Just copy this Clipper UF2 file to the mount directory. Again, sudo unmounting. We're going to disconnect this drive, and I guess after that, I think we can just disconnect it or reset it. We're just going to hit the reset button once. And after resetting this little garbage truck, we are going to list again. And we have our devices. It's now again showing up as this OpenMoco, which is the Clipper device, not the Raspberry Pi boot drive. And now I should be able to get the serial number from it. And we'll make sure this is the Pico Bellicle. That's the serial number for that device. So we have that in our little cheat sheet for later. Now we can do the same, because since we're already doing this, we can do it later for the screen. The screen is something we can attach in another day. So we have all the clippers, all the clipper devices that we are connecting. We have them ready. So last step, we have both devices powered up. Now they should also show up both. And that's what we see here. We have both devices now powered on. However, in the end, we do not want to drive the power for either of these boards from the Raspberry Pi. We want to drive them individually from the power supply. So that's, we have to see when we are ready for that. But I think from that perspective, we are good. We have flashed the firmware. Yeah, we need to check what config file we need. Configurations, we have following the steps. We bundled settings. I think we need to combine our config files now. We have as the first thing, going back to the, where are we here? No, I think this is something we can close, because we don't need that anymore. This is, we compiled in Flash Clipper. We can also close that. Now we need to configure Clipper first. Without thinking about the Pico Bellicle, we just configure the base configuration. And if you followed our wiring guide, we can use the pre-made configuration files. Let's open that directory. That's the printer config. I think we can just go and download this file. And then we can simply open that, copy everything from this file, and go in our main sale, printer config, paste. So now we have essentially just taken everything from the Voron pre-configured file and pasted it into our own printer configuration file on the Raspberry Pi. And the last thing to do is we have to fill in these two serial numbers. We need the serial number for our SKR Pico, it's the first one. That's this serial number. We paste that here. And then we have another serial number for the Pico Bellicle mainboard. That's this here. Good. And we can double check all the rest. Things to change and check. The MCU path we did. Set and extruder motor currents. I think you have probably need to check that. Full steps per rotation, thermistor types, extruder motor currents, pit tuning, fine tuning. These are more or less things that need to be done sooner or later. But as they say, it should actually be so much pre-configured that it works with this kind of kit. So I'm not going to explain all of this section here. We're just gonna assume that we can save and restart, and we are lucky, and if it works, we'll see something happening. Not sure if this is already everything that we need to do. ADC out of range. This is generally occurs when a heater temperature exceeds. Yeah, That might be because we have not connected yet our cables to the toolhead, but what we can already see that our clipper is already detecting the SKR and our picobellical board, and this is our host. Everything seems to be up to date. So what's the next step is really we need to configure, we need to connect all of the remaining cables, and we need to make sure that we are powering up from the power supply. So let's do that now. From the software side of things, I think we can now check last steps in the manual. So this is already skirts and panels. So from this perspective, we are done. But still, I think in the, let me see, we have a picobellical guide where we had to, I think we skipped one step here. Did we? Wiring the toolhead PCB, yeah. So we can wire up stuff. What I will do, I will shut down the Raspberry Pi. And disconnect it from power. And now I will wire up the Raspberry Pi so it gets its power from the picobellical. Now the picobellical still has the USB power plug. We remove that. We also remove the USB power from the SKR, so nothing gets power over USB anymore. Then I have a very nice helper. This is for Raspberry Pi users. This is kind of a little helper PCB that tells us where are the pins, or what are the pins for what purpose. So if we look at that, we can see we have 5 volt is the first pin here in this corner. So first pin in the upper right corner is 5 volt. And then there's a ground pin, that's pin number 3, also first row. So we use that. Pin number 1 and pin number 3, we should be able to power up our Raspberry Pi from the 5 volt that come out here. So that's quite useful, and you always know if you need to figure out which GPIO pin is doing what, where is it. You can use these kind of. You can also permanently have them pushed over the pins if you want. I think for someone who's using Raspberry Pi frequently, this is helping you save some time. Always looking up, oh, what pin was it? Where was this pin? That's really useful. Now on the bottom, I also want to finish the covers here. So we want to push over the cable channel covers. Finishing this part of the story. So that's clean. The only thing that I realized also this morning, we have printed this cover here that's supposed to protect these connectors where we have 220 volts. The problem with this cover is I think it was designed for a different power supply. It's not really, there's nothing to hold it. I think the idea is good, but it's the wrong cover, and that was in the original build guide, so it's not going to work. Okay, we should now do a first test with main power. We'll see if everything is starting as we expect that, and if nothing blows up in flames. Shall we do this? Are you ready? Are you ready for the power up? I'm not sure. Switching the button. Switching in 1, 2, and 3. Okay, so I see we have power here, we have power for the Raspberry Pi, and we have power for the Pico Billicle. It's booting, so we should see it in the network in a second. Let's see. Nothing blew up yet, at least. And does it work? Is it booting? Let's see. Let's see when it shows up. Excuse me. Not yet. Still logging into the network. Ah, did use the wrong IP. The wrong IP address. Okay, it's there. It's there. Okay, it's good. SSH. Good. Stuff is running. Nothing serious. Actually, it's very much doing nothing. We can now go back to our main sale page. Is it now starting? We didn't yet connect all of the cables. I think I'm gonna shut it down one more time. So, one thing, just going to unplug it. So, we have proven that cable's power is working. One thing that didn't work was this little fan down here, but maybe it is also, I'm not sure if it's permanently running, supposed to be on all the time. We need to connect all of these cables now. It's not the easiest thing to see. Can try to zoom in a bit further. So this is the Toolhead PCB for the Pico Billicle. There is one huge cable. This is the connection cable. We're going to do that as a last step. That's connecting this plug with the Pico Billicle plug here. And we can also use this nice wrapping tube to protect the cable. I think we can also do that right now to see how long it should be. So we can probably cut that . So how much do we need? Probably right here. So I'm pretty sure that this, we should make that straight. We should also, do we have a lighter here? I think we have a lighter here. So we should probably, yeah, it's not the most. Just make sure that the ends are sealed. Okay, maybe a little more. Okay, so that this thing survives a couple more prints, using a lighter, sealing the ends. So with that, we have prepared this, hopefully enough that we can now start connecting cables. Okay, keep that for later. We'll do that in a second. Now, let's start. We have a motor cable. It goes in here, and of course, I'm kind of wondering how we organize the cables around this tool head. Here we have a little place where we could use a zip tie. I think that's what it's supposed to do here, is we're gonna insert a zip tie here. So we can fix this cable on the side, because the printer, tool head, or the cables are also gonna scratch, or yeah, probably might be rubbing against the frame, which we do not want, of course. So these are two cables we want to keep away from the frame. That's one. So these are hot end fan and part cooling fan. I need to figure out which are the connectors now. Same story on this other side. We also need to make sure we not have the cable pushing on against the frame. So same story here. We have a little slot for a zip tie securing this cable. Question is really, what about this cable here for the heater? Is this actually a place? Do we want to run this on the back? I have to look that up. I don't know how they are running the heater's cable and sensor cable. Is this also running? There's nothing in this manual about that, honestly. Maybe we need to go back to the original Voron guide if they have any advice on how to do proper cable management for the tool head. Here there's a few words about that. Organization is key. This is the intended path for routing cables such as the heater, thermistor and fan wires. So they should be what they're saying, the heater wires tend to be thicker than other wires, so routing them to the opposite side as the thermistor and hot end fan wires can help things, keep things balanced. Okay. So they recommend that we do all of the cables here to the side. Now my question would be, is there additional zip tie slots anywhere? This is otherwise a little difficult and hard to see. You see these two wires here coming out of the tool head. we have a heater cable and we have a sensor cable. Now if I'm starting to run them alongside of the printer, just like that, there is nothing holding this cable down here. And honestly, I do not like that. I do not like that. It's very close to the belt. Too close to the belt, if you ask me. So how would we make sure that the cables stay away from the belts? That's interesting. For the cooling fans, I understand how this works because they have a little channel here. On both sides, we have two, each side has a little channel. The cables are just coming out there and we can stretch them a little bit, or we can pull them so they are straight and they're not touching the belts. However, for this cable, I'm not sure this is the right thing. There is this doesn't feel right, and it's also the wrong side because there is our terminals on this side here, so we definitely have to run it on that side. Okay, so theoretically, when this cable is connected here, this is the place where it will be. There's this little terminal here. Where we can hopefully open up enough so these super thick, oh my goodness, these pins are so thick and they are also quite long, so shorten, they should hopefully not shorten. Probably have to isolate them a little bit better. Do some, I don't know, some tape around it. You see there quite a lot of length here, probably 2 millimeters of these connectors are sticking out. So we probably have to use a cutter and make them shorter. This is a little too dangerous for my taste. So let's see if we can make them shorter. It's definitely 2 millimeters we have to remove. Don't want to have them sticking out that much, that's better. Same here. Can you please get in here? Okay. So, not too bad, but where are these cables supposed to be fixed? Is there any way to fix them so they are not interfering with our belt path? Interesting. There might be some slot here, which you cannot see at the moment, but I could imagine that this is for a zip tie. Yeah, there is something to hold cables down. I'm sorry I cannot show you this. There is basically all of the electronics is blocking your view at this moment. But I will try with a different camera in a moment. Okay, so what's the idea? holding this down. Is this the whole idea? Okay, let me get my other camera in so you can see more. Okay, so this is quite an installation, honestly. More complicated than expected. So what I'm doing here, we have these cables here from the heater. We have the heater cable. There is a place for a zip tie here and another one here. So we can strap it down so it stays basically away from the belt. The belt is just right here, so we need to keep the cables down and also on this other side. However, the cables are also not like that much, don't have that much length that we can just, yeah, if we want to use this place here for the second zip tie, there's going to be a lot of tension. So we have the choice of, I think we need to move this, turn it over, so we have a little bit more cable on that side. This one is longer, a tiny bit longer. So let's figure out how much cable we need. How much do we need? I don't know, do we need this? This is the serial number thing. I think we're gonna remove it. It's just in our way. Okay, so now we can hold this cable down together with the fan cables. So everything is staying away from the belt path. Still difficult to see, probably. This is where we are. So let's get new zip ties because it's one here. Okay, so we'll strap that down in a second. We want to make sure that we also can connect this cable, that we still have enough. So we'll do the same on the opposite side. I want to strap down the cable here and also here. So using the same slot. It's all so tiny. Oh my goodness. Okay, so do we have enough to connect? Which pin? Which plug do we need? And it's not focusing, my goodness, what is happening? Okay. Loosen the nozzle a bit so you can turn the heater core to get some slack in the cable that's too tight. Okay. Let's try that. Let's try that. You can still do it to it again. I think we have the cable is very short actually, so it's very much the case that we have to use everything that we can use. Everything that we can get, we need to use. The heater core is facing, there's not much stress here. It's actually, the only thing is that this cable is protruding out from the heater core quite a bit. There's probably some metal, some piece of metal that's straightening it away, or it's keeping it straight for probably 2 centimeters until you can bend around these cables. This is, yeah, we can now, actually we can give back. Can we give back a little bit? No, we can't. Yeah, there's not much slack. We cannot really give back any of the cable, honestly, because that we have to strap it down also here, and we need that, and it's all very tight. It's very, very short. I wish there would be 1 centimeter more cable. Okay, what are the connectors for the umbilical cable? We're looking down like that. I'm going to start with the sensor. What is the thermistor cable? Thermistor cable is blue. That's the left one. That's good because that's the closest to this side. Okay. That's actually good because that is the first connector. So here we have, that means we have a little more room to play. Not fixing it completely yet. Now, what's the next one? Motor cable, of course. Obvious. This goes in here. Probably you can fix that somewhere to the side. We have, this is very short. Maybe we want to come here. Can we? Okay, so let's figure out where these 2 cables have to go now. Okay, so are we missing anything? I don't think so. Okay. Now we need to figure out which connectors these are. This middle pin is the X stop. X stop doesn't exist. We are using sensorless homing. Then the other one is the heater, the hot end fan. Hot end fan. That's this one here. Yeah, hot end fan is here. And here we have 2 part cooling fans. Are these the part fan 1 and part fan 2? Okay, great. So this is part fan 1 and part fan 2. So let's strap down cables a bit better. Double checking that nothing is really touching those belts. because they are very, very close here. You want the cables really to stay away from the belt path. That looks, for now it looks good. I would say we can go with that. The only thing here is probably the organization of the cables up here. Then a little bit more, should make at least probably one zip tie holding these two here in the middle. Just a bit. There is nothing to fix them. I think we can just do it like this. Things are tidy. Like, can you do like shoes? Just pulling a little bit. Okay. And finally, motor cable. I would have one here. Here around that distancing part. The strain relief is probably a good place to also put a zip tie. So how does it look? Lots of cables, but everything is nicely connected and nothing is protruding out that much. Nozzle is in and these cables are running straight. So we're cutting off the zip ties here, the ends, and we should be done. Good. Final thing to do. Final thing to do, connecting these, the main connector cable. Okay, so this plug goes in, clicks, and the other end is connected up here. It should be this way. Is it, or is it the other way around? This way around, okay. Clicks in place. Nice. That's it. Okay, I think we can have it up right now. You won't believe it, but this printer, from a technical point of view, the printer should be ready to print. So let's have a look at the mainsail. Does it now? Oh, we need to power it up. Power, my friends. Only thing is, why is this little fan not running? Is it supposed to be on or not? Probably want to measure quickly what do we get here. I think we don't get any power from here, do we? Ah, there's nothing. Okay, so I'm not sure if that little fan should now have some power coming for cooling. It's not, doesn't look like at the moment that any of those pins are powered up. Good. So no errors anymore. No problems reported. Okay. Now, virtual SD card is not defined, pause resume not defined, T-code pause, T-code cancel print not defined, display status. Yeah, okay, there's a couple of macros are missing. Nothing. Let's check out these sensors. We have 27 for the extruder temperature. Heater is 22 degrees. Chamber, I don't know what that is. Probably that's coming from the board. Okay, what could we do? Let's check the heaters first. Let's see if we can heat up the nozzle. Okay, so I hear the front fan is running. Okay. Once I turned on the heater, that little front fan off, that fan here started running now. Temperature is coming up. That looks great. Let's turn on the heater bed, 50 degrees. See if that's warming up. It's also coming up. Okay. So, looks like the heaters are working. Set it back to 0. Let's see what we need. I think this is the printer config. Close that. We did all of the wiring. So I think we can head over to initial startup guide. Startup checks. We're verifying temperatures. We have the temperatures we are heating. That's good. So how's our bed temperature doing? 40 degrees. Okay, it's coming up. So from that, looks good. So what can we also check? To verify that each stepper motor is operating correctly, send the following command in the terminal. Stepper bus, stepper is my step X. The stepper bus command will cause the given stepper to move 1 millimeter in a positive direction, and then it will return into its position. We can try that. Let's go to the console. So let's try stepper bus X. That should do something on one of the motors. Okay. Let's try again. Which motor was that? This motor. Okay, it's moving slightly. Let's do the same. Okay, that motor is turning slightly. Then we do the same probably for the Z motor. Z motor. Yeah, it's also moving. Z motor is working. Finally, the E motor. It's not called E. How is it called? Heater or something? What is it called? Extruder. Okay, it's called extruder. Extruder. I can hear it moving. So extruder motor is making some sounds. Okay. So this test is done. The motors are all working. What else? End stop check. Query end stops. Okay, let's query the end stops. Triggered open. What does it mean? Make sure that none of the X, Y, or Z end stops are being pressed. Send a query end stops command. The terminal window should respond with. I think we forgot one thing. We have to install 2 jumpers on. Here's my jumpers. We need to install 2 jumpers on the Pico board. I will just switch it off again, and I will just install these 2 jumpers. Each jumper goes to one of the stepper motors, or is one for one of the steppers here. Extruder. Z. So here we have an end stop switch. For the Z axis we have an end stop switch. For the E we don't need an end stop switch but for these 2 stepper drivers we need to set the jumper, because we want sensorless homing. And only with the jumpers set we get sensorless homing on these 2 motors. Switch it on. So starting again. Now we should see that the end stops are working. As soon as we have it booting up. Here we go. Try again. So we should have query end stops. All of the end stops are open now. That's good, because now we know none of the end stops is currently triggered, and we did have X closed and Z and Y closed before, because we didn't have the jumper set. Now let's go further. Homing check. Okay. Now here comes the critical part. Homing check is really important. We need to figure out if we have a motor direction set correctly. So how do we do that? We don't have an emergency stop button on this printer yet. We have not, as we don't have the display installed yet. So I will have to let me split screen here. So we will definitely need to be super careful and have the finger on the power button. Okay, so we can now try to home both axes. If we home the x-axis, let's see if that works. Let's see if we can home x. And I have my finger on the emergency stop button. Okay. Oh my goodness. Let's do that one more time. What was that? Something sounds strange, honestly. Why is it? Sounds a little bit like some belt is rubbing against something on the frame. Why? Can that be? I hope not. All of the belts are on their pulleys and not running somewhere where they're not supposed to be. Let's see. There was kind of a strange noise. I don't know why. Why is it making such a weird sound? Sounds strange. Makes some noise. So the belts are, this belt is not really very tight, if you ask me. Let's try this one more time. Strange. Can we shut down the motors for a second? Let's disable all of them. So, where's this noise coming from? It's very strange. I don't hear that noise when I move it manually. That's clearly coming from the motor. Crazy. Okay, so let's figure out where we can Can see stepper X and Y. Where should it move? Move to the back until the Y and stop in the core XY configuration. Both motors have to move in order to get the Toolhead and to go in only in X or Y direction. So we should see that for this X homing command, printer should move to the right, which is here. And then it makes this strange, when it goes back to the middle, it makes a little strange of a noise. Okay, and Y should go to there. Yeah, that's right. And again, where's this noise coming from? Nobody knows. Okay. Is this maybe the Z-axis that is trying to move against the stop? Not sure. What happens if I tell it to home Z? Is this a good idea? Okay, what should happen? The toolhead should move up slightly and then move to the right up. The toolhead should move to the back of the printer. If the gantry moves downward first before moving to the right, okay, let's see. Gantry moves downward. Downward means away from the printhead. Okay, so let's try something. Let's disable the motors, and we are bringing up the gantry slightly. Okay, somewhere to the middle. Let's home X. Okay, so the gantry is moving down quite far actually. Okay, so the gantry moves down. Should probably not move down. That end stop location. Okay. Switch. The end stop switch is connected, right? It should be connected. My impression is that the Z end stop is not triggering. It should be. Let's check the end stop status again. Now it's completely down. And Z is triggered. Okay, so the Z end stop is working. It's triggered. It's triggered. me make this. Let's see, can we let's see, can we reduce the chat window a little bit? Okay. So we get a little more space here. So what I see is the ZN stop is triggered. That means it's working. However, the printer is still moving the gantry down. It should not be. So can we say ZN stop calibrate then? Let's fix that. Okay, that's can we home that? That homing seems to be. Uh-oh. I'm not sure if that was a good idea. I switched off the printer because I was saying G28Z and it was going down. Let's see. Bad locating, define point. Where is the ZN stop pin location? ZN stop location. No, the switch in our case, the switch is not where the nozzle is exactly touching. I mean, the end stop switch is at the lower end of the gantry, honestly. Yeah, after homing that, you can use the ZN stop calibrate. Okay, let's be brave and home that. Okay, gantry is going down. It should hit the switch. My finger on the stop button. Oh, is it not doing anything? Okay, so it's homing that. Okay, so it's completely down. What can we do now to do the ZN stop calibration? Let's do a complete homing. Finger on the stop button. Okay. How much space? There's probably 1 centimeter. It's quite large. So let's do, where's my print surface? Okay. Let's get the print surface on. Maybe let's give it a little clean. Okay. Let's see. Okay, there is no helpers here to center that, but it's on. Okay. Now we can do ZN stop calibrate. We can move it up. Okay, so now paper. The good old paper. Okay. It's too much. Paper is too big for this printer. Okay, so that's already a little too much. I think that sounds good. So we should be there. Okay. We don't have an inductive probe. Okay, let's do pit tuning. That's G28 again. So we're homing one more time. Okay. So now we're doing a pit calibration. And in the meanwhile, I'm gonna open up Orca Slicer. We're starting Orca Slicer, my friends. You know what's happening. But I don't want 191. I think I want the latest Orca Slicer. Download. So we don't want the old version. Official release. Let's get it. So we're installing Orca Slicer 2.0.0. We're getting close, my friends. We're getting close. So what we need now, we need to check installation of the PTFE tube. Where do we have it? Is it somewhere in one of the bags still? I think there was at least there was a long enough PTFE coming with the printer, if I'm not wrong. Was it? Did they deliver a PTFE tube? Yes. Okay. They did. We can also put our little heatsink on Raspberry Pi Pico. Hey! Thanks for subscribing. Thank you for subscribing. I missed who it was. Mr. Nicewise, thank you for the subscription. Okay. For following it, well, to be more precise, it's not a subscription, it's following. So I'm installing this oversized thing on the SCAR Pico just in case. We need some heatsink. Looks awesome. Now, pit calibration is it doing anything? Yeah, obviously it's heating up the heated bed, I said we're gonna go for 50. We still have this config problem. Main cell config needs to be included. We can do that once this is done, and then we can hopefully get rid of all of these issues. I want to install Orca Slicer 2.0.0. Let's do that. Yes. Yeah, here we have another console. Yeah, that's right. Thank you for the hint. Still doing its thing with the pit tuning. What about Orca Slicer? Finish. Okay, so let's launch Orca Slicer. I think there is a default profile in Orca Slicer for the Vorons. Let me see if the V0 is also part of that default list. So let's do a new project. We are going to check list of printers. Voron. Let's see, is the Voron 0 list? Is this part of Voron 0.1? I'm not sure. We can tighten and also, I think I did it, yes, I tighten it, I'm just wondering, Voron 0.1, is this a profile we want to use? I'm not sure. Maybe we can install a profile from the website. Let's see if they have something. When Benchy. Okay, when Benchy. T minus 10 minutes. Slicer setup. We're still on pit tuning, right? Let's wait for the pit tuning. I think it's done. Is it? Or is it not? Still running? Yeah, it's still running. So we can, in the meanwhile, we can install the PTFE tube. So how it's supposed to work is we start here. Not sure, is there anything holding it? I think there should be something. I'm not sure. Is there from the yeah, I mean, I've done that, right? Everything is in place. So I'm actually wondering, we did was there anything installed like a coupling here? Was there any coupling installed? Not sure, to be honest. Let me see if that. I'm wondering what is holding the PTFE tube in place in this extruder head. I was just wondering, how is this held in place? What is holding it in place? There is no coupling in the Revo, on the Revo side. Do they have the step explained about the PTFE installation? I'm wondering. Electronics. Skirts. Yeah, okay. We do the skirts later. Panels. Yes. Cable pass-through. We don't need that because we have this other picobellical where we are running the... Yeah. This is not needed. So question is now PTFE tube. PTFE versus FEP. Let me understand how this is supposed to be fixed. So we are running the PTFE tube from the toolhead down to the printer frame. Okay. Length of the Bowden tube from the motor panel to the toolhead should be about 250 millimeters. But is it being held by anything? Seems there's nothing holding the PTFE tube in the toolhead, is it? That's weird. All we see is your shoulder. Sure. Cobalt Ethan, thanks for following. Hey, guys, can you still see the manual? We should currently see the manual. I hope this is working. Okay. Are you trolling me, my friends? So I was wondering, this PTFE tube is essentially ending up here, but I was just asking a question, like, is anything holding this? Seems not, right? It's just we just stick it in. Then we have it running down here. How much do we need? They say about 25. What was it? About 250 millimeters. The length of the Bowden tube from the motor panel to the toolhead should be about 250 millimeters. So let's measure that out, right? And make a little marking. So we then just have some kind of reasonable length for that. Okay, so 250 millimeters. Okay. So let's see how much that is. We pull it down like this. Where's my mark? Here we go. It's not so much. Okay. We can do zip tie in here. I think that's how this should work. That's just to secure the thing. It's not coming out, but nothing more. There's nothing holding it, and like there's nothing seriously grabbing the PTFE tube. So if it wants to move, it can move. This is what I think. Yeah, okay, but not much, not so much. The length is somewhat fine, and then now we are running it into this very much straight down into the coupling of the filament sensor. So I have a nice cutting tool. Let me get it from the workshop. Actually, I need to head over there anyways. Checking the printers. I think it's with the fish fork. One more done. Project. Much is left here. Okay, fine. Okay. Well, we'll do it with a. Good. So far, so good. I'm gonna just cut it with my cutter knife. It's good enough, hopefully. Okay. So let's put it into the coupling of the sensor foot. Now we have the PTFE. It's running down here. It's going into the sensor, which is in this foot here, where is the filament sensor, right in here. And then the filament comes out on this corner. We have one. We now need a little bit of filament, PTFE on the other side of that foot, just that they connect. We don't need that much here. What we can decide later how much we want. Just leave it like it is for now. And we'll just use filament spool roller to feed some filament in. Something like this here. Do I have a spool holder here? Maybe. We have that original spool holder. We can also use that. I mean, just need to figure out where we will have our spools mounted. Where is it? Spool holder. And there's some part to fix that. Spool holder mount here. Okay, where do we mount the spool holder? I think it was it in the back? Yeah, it was in the back. How many of these nuts do we have? 1, 2, 3. I think we can temporarily just use one of them to mount the spool holder. Spool holder is going to the back of the printer. I guess like this. We can then decide, I think it's somewhat like this. I'm not sure 100%. Like this, or like this. I think this is for storing the spool holder away. And this is for, but it's very tough to get it off. You probably have to, use it a couple of times so it's at least moving a bit easier. It's getting better now. So, say we mount it here somewhere. We'll need one screw. I think it's M36 or something, or M38 is probably good. Not sure M36 or M38 is enough. Probably we need a longer one or a 10 millimeter. I think the 8 millimeter is also too short. Let's use the 10 millimeter. Okay, so we'll just do it temporarily because I guess since we will do the panels later and the top head, that we also have to figure out where exactly we need it. So let's place it here. You know what? Make our lives a little easier. Just gonna move that up here. Grabbing. No, it's not exactly. Where's my screw? Is it here? Yeah. Hey, my friend, can you please grab the screw? Okay. Why is it not working? Should be the correct diameter. Or are these smaller screws? Oh, this could be 2.5 millimeters actually. Could it be? Honestly, I don't. M2? Not sure. No, I don't think so. It should be good. Why is it not working? Is this nut maybe damaged? Or faulty screw, maybe? Let's see again. Seems to work now. Okay. So where do we want this? Maybe like this. Spool. So let's look at it, how this is supposed to work. The spool will be here. We will have our outlet somewhere here. We don't want to cut it too short. I'd rather have a little more PTFE tube than too little. So let's assume we're somewhere around here. Okay, so that should be good. Is it working? Oh yes. But the thing with the tool head, that doesn't make me happy, is it's not really staying in its little slot here. Why is it coming out? Is this supposed to stay in there? So I'm just wondering, did I make something? Did I make a mistake here? It's not really explained in the manual, honestly. Not anything specifically mentioned about. And why is my frame rate so low? Friends, why is it stuttering so much? So the PTFE tube is installed theoretically. Open the latch. Let's see. I don't know. Is there, honestly, there isn't. Is there anything holding the PTFE tube? Now I know what. Is this maybe this little garbage truck of screw here that's supposed to fix the PTFE? No, I think that screw, what we see here, is supposed to be limiting the latch movement. It's not really working. I don't fully understand this, how this is supposed to stay in its place. There's nothing there, or I don't get it. It's not fixed in a way. So let's see where we are with the temperature calibration. Is it still doing its thing? Heater bed calibration still running? Seriously? How long is it going to take? Shouldn't it be 1 8-inch thread to 4mm hose fitting there? Let me get back to the manual and figure out if I missed something. I'm just checking how the toolhead is working. The toolhead has there's obviously this hole for the PTFE tube. This is confusing me. Should we glue it in place? They're not telling us this thing, right? They're not telling us this is how you will fix your PTFE tube. Weird, very weird. That's actually surprising. Yeah, maybe it's just a guide. I get it, but it's also kind of weird because if you push the filament in from the spool, it's potentially pushing out that PTFE. Maybe fixing that with hot glue or something, at least a little bit, but it's also a moving part. Might also be not a good idea. Let's move on. Let's not waste any more time. I want to print. The pit tuning is still running. I feel that it was a mistake to do, you know what, fuck it. Let's include mail-say config. Let's save and restart. Forget about the pit tuning for now. Okay, let's see if we have any more errors. No, we don't have any more errors left. So I would say let's go to, let's find out what we need in terms of config files. So do they provide us with anything? Slicer setup. There are 2 slicers that come with built-in profiles. Other slicers can be configured. I think if we just simply go and go with the generic clipper. Where is it? My clipper. So we're going to modify the generic clipper command and say a Voron 0.2. So printable area 120, 120, 120. Flavor, blah, blah. So just leave everything as it is. Before layer change, after layer change, blah, blah. Print start extruder bed. Just have to check if those names are correct. We have basically we have 2 things here. We have we obviously have the extruder and we have heater bed. So we need to use print start extruder and bed. We need to check if that print start save it. If that print start template works. Retraction, blah, blah, blah. I don't care. We'll probably just use that as it is. Normally it works fine. I did it on the D100. It works pretty much as it is. Generic PLA. Okay. We'll also connect the printer. Hostname 4441. Connection works. Load Benchy. Benchy, personal models, Thingiverse, Benchy, files, Benchy. Okay, slice the Benchy. So let's load the filament. I think we didn't change anything here. So we will just load the filament. Let's heat up to 220. Let's feed in the filament. Do we have a load filament script? Print start. We don't need to double check what is in our print start command. Print start. Okay, it's not preheating anything. Okay, the print start command is pretty much very much simple. Not sure if the print start command currently supports the temperatures. I will just steal from my Ender 3. We will just steal the print start command because that supports preheating. Let me see, I think I'm in the wrong directory. Decode macro, here we go, print start. Where is it? Load material, I think where is it? I think we didn't modify that actually. Okay, maybe we don't need to. Maybe we don't need it. So let's just assume that this is working. We will load the filament manually for now. We don't have a load filament script, I guess. I think not. Oh, we have one. Oh, we have one. Okay. Let's see if we can load the filament in. Okay. I think the length, 250 millimeter length, is clearly too little. That's definitely too short. Why are they telling us that 250 millimeters should be good? That's not enough, honestly. Anyways, we're gonna fix that later. And our motor is going in the wrong direction, if I'm not wrong. So we have to reverse. We have to reverse the motor direction. Okay, we're gonna quickly replace that tube. Okay. Okay, let's try this one more time. Load, where's my script? Come on. Load filament. Okay, it's definitely going reverse. So it's definitely going reverse. I wasn't mistaken. So we go to the extruder config, stepper, extruder pin, direction pin. So we just do an exclamation mark and save it. That's it. And that's how you reverse the motor direction. So we'll do load filament one more time. Hopefully this time working in the right direction. How about the temperature? Is it setting the temperature to something reasonable? I don't think so. Oh, it is. Okay, it's heating up. Come on. Take the filament. Please. Feed the filament. Come on. What are you waiting for? Okay, so now it's going in the right direction. Pulling in filament. When is the filament coming out? Here we go. We are extruding filament. Okay, so that's great. Let's send the Benchy. Let's just do it. Okay, friends, I have sent the Benchy. Benchy is sent over from Orca Slicer. Printing. We're heating up and just waiting for temperatures to come up. Why are the 230 degrees? Oh my, this print profile is weird. Why is it printing at 230 degrees? I don't know. Or maybe it's just for the warm up. Okay, strange. So waiting for the heated bed to warm up. Come on. Give me that. Give me that. Don't ooze here. Oh my goodness. Do it. My friends, we did it. We built the Voron Zero. We have quite a couple of things to do. We need to do the panels, the door, the top hat. But if we can get this Benchy printed now, we made a huge step forward to finishing the whole build. One bang. One bang. Oh my goodness. We definitely need to implement some nozzle cleaning procedure. Maybe you can find some nice. Get your hairdryer on the bed to heat it faster. Check that. Well, the primer is powder, so you have to apply it flat. Primer and glue. I don't know what are you doing. I think you're talking also about something else you're doing. Okay, what is happening? Printer's homing again. I am so curious now. I'm nervous, a little bit nervous also. Uh-oh. I think we are very much too close to the surface, if I'm not wrong. Okay, let's adjust the distance. Just trying to understand whether we get too close. But I'm just adjusting the offsets. Okay, we're still too close. Getting better now. Okay, so let's. I think what we definitely should do is check the corner leveling one more time. The distance seems to be good so far. Probably the bed is a little bit tilted, but for that tiny bed, I think we can do it. It will work. And we are printing. No, it sounds good. I think we have to do a proper corner leveling procedure. Still, it seems that it's not detaching or something yet, at least, but we should do a proper... Yeah, we're gonna do a real Benchy video soon. I guess we will have the chance to tune the profile a little bit. Yes, it's more or less slow. I would consider this to be still quite slow. Can we push the speed a bit? I don't know. Can we print faster? Okay, that's 200%. I'm wondering, are the cooling fans working? Yeah, okay. Okay, let's speed it up. 300%? When is the extruder flying through the air? I think we have a cooling issue here a little bit, if I'm honest. You see, print is a little bit warping up, so we definitely are not cooling as good as we should be cooling. So probably the print temperature is too high. I would reduce it. I suggest that we do one thing. We reduce the print temperature. Is the fan running at maximum speed? Where do we see this? Do we see this somewhere? No, it's running. It's supposed to run at 100% at least. Strange. Okay, it's getting better now. So you see the warping has stopped. So I reduced the speed down, so it came back to normal, and in a way the bow warpings did stop now. So it's clearly a cooling problem. We definitely have not enough airflow. Both fans are running, right? Yes. Okay. Okay, it's not the nicest Benchy ever, but it looks that it's gonna stick at least, and we're not gonna fly off the build plate. Okay, can we? Let's speed up a little bit. Let's push it to 125% maybe. No, we're not timing yet because I'm modifying the print speed on the fly. So we'll definitely do another one. I want to do proper corner bed leveling first. We also probably want to tune the filament a bit, so we find we're gonna tune extrusion factors and also the K value. So let me see. I think it's probably disabled. Pressure advance is disabled, so we should probably tune the extrusion and the pressure advance a little bit so we get some more proper calibration for the filament. So that is Filamentum PLA. So let me create a new profile for this with pressure advance, temperature recommendation. I'm just looking it up. I think the standard PLA, extra fill PLA, red traffic red. Recommended print temperature 190 to 210. Okay, it's definitely lower temperature. And bed temperature 50 to 60 degrees. So yeah, probably also 55 or something is good enough. Volumetric speed, we should probably also should figure out what is the volumetric limits for this hot end. Density for the material, technical data sheet, let me check that. Technical data sheet 124 gram, that's right. Glass transition 55. So it's definitely a lower temp material if it's already transitioning at 55. Normally you have 60 degrees glass transition. Okay, so I'm going to create a preset for this material now. In the meanwhile. And I think from the speed settings, I would say we're definitely on the lower side of things still. Acceleration values can be increased, in my opinion. Let me see what's set in the machine limits. Retraction values also need to be tuned, I guess. Oh, it seems that mainsail has crashed. At least I don't see my GUI anymore. Still printing fine. Question is... Looks like my network, the network is disconnected, so it seems that it's lost. From SSD? From SD, yeah, it works. No, what happened, I think it has lost Wi-Fi connection at the moment. Wi-Fi here is maybe not the best. I mean, sometimes that happens. That happens also with my other printers. Sometimes they just disconnect from the Wi-Fi and then 5 minutes later they are back. and for some time they are just not finding the Wi-Fi. The printer is still working fine. I think it's just Wi-Fi disconnected. Yeah, we should wire it up. It's better. Long term, it's the better solution. So I want to see the printer config file that was provided with, let me see, electrical installation, software. What is set in the defaults here? Acceleration values, acceleration limits, default 2000. I think that's too little. Honestly, 2000 is too low for such a printer. That's very, very careful, or too much conservative values. I would push it higher. Exactly. Wi-Fi is garbage. If you need reliable connection, it's not working. I don't know what's happening with the Wi-Fi. It's probably just crap. Is the studio Wi-Fi still working here? That's strange. The studio Wi-Fi is still working fine. I'm sure I could figure this. That's more a Raspberry Pi problem, maybe. Anyways, if we figure that the Raspberry Pi that this specific Raspberry Pi is not working properly, I will just replace it and basically do a drop-in replacement for Raspberry Pi 4 or the Big Tree Tech Pi. Well, probably more the printer hammer to fix the Wi-Fi. Router goes hot. I don't know. No, I think it's a Raspberry Pi. I think it's also, if you look at the printer, I think it's kind of throttling. The problem is that I can't log in anymore. So my guess is that the Raspberry Pi 3 has some kind of a performance issue. I'm not sure, but for me it looks a little bit like the printer is struggling to keep, like it's not fluidly moving, so it's like kind of stopping. Very strange. We can try to cool it down. I have a little blower fan here. See if that helps. Okay, I'm sorry. I'm sorry I didn't warn you. Maybe I should have turned off the microphone completely. Sorry. That was a mistake. Yeah, I guess something's wrong. I don't know what's happening. I think the Raspberry Pi is struggling with something because it doesn't show up on the network anymore, and it's kind of running slow, if you ask me. Stuttering. I mean, it will probably finish the print. That's the interesting part. That it's still running, the printer, but it also seems that it's, I don't know, it's not able to keep up with the, or is it just doing too many retractions? Am I maybe completely wrong? I think every time it's slowing down, it's retracting. It's definitely too many retractions, so we need to dial back the retraction settings a bit, have less retractions. Number of retractions definitely too much. As soon as it's moving, it looks actually okay, but then it's stopping so many times for retractions. But maybe that's okay. It's just a slicer topic. The other thing is really what is going on with my Wi-Fi. We can try to plug in the network cable, see if it just fixes anything. If I can find a cable that's long enough. We need 2 to 3 meters. Let me see. Should have something that is long enough here. Is this long enough? Let's see. I know. We have internet connectivity problems again. What is going on? What is going on? I hate it here. So let's move. Okay, let's stop this. Schedule. Okay, save. Okay, does it work for you? No, don't have. It's not working. Bandwidth is going down again. Okay, this is stopped. Okay, fighting with the issues. Yeah, feels like 4 frames. I totally agree. We're dropping frames like crazy. I don't know why, honestly. But I'm on it. I'm on it. So, my best guess is that we're now up and running again. I hope so, at least, and I hope that we don't have any frame dropping anymore. Let me know. So, how does the stream look like? Is it still working? Unfortunately, some issues. I think I've fixed them now. It's always this midnight issue. I have to figure out what that is, honestly. Don't know what kind of job is running at midnight. That's doing so much data transmit. Twitch don't really like 1440p, but it still works, right? We can force it into 1440p with 6000 kilobit. But it's, yeah, maybe a little bit of an inconsistency with Twitch. Let's see. So we're still printing our first Benchy, but I really want to push it. Like, it feels a lot too slow. I'm actually like, do we want to stop that print and do we want to push it harder? I don't want to wait so long anymore, honestly. It feels very slow. So I'd rather have some tuning going on now and really push that limits of the printer slicer profile and also the printer settings. Should we maybe stop it? Yeah, Z-hops. It's way too slow. Honestly, I don't want to wait for that to finish. We want something faster. It's not a speed Benchy. Okay, let's cancel that print. It also looks terrible. So what we should do now is definitely do some corner leveling. So we can fix the corner levels first and then do the rest. Let me see what we can do in terms of can we do corner leveling? I think we do have to do it manually if I'm not wrong. That's unfortunate. So is there any kind of pre-made script for corner leveling of the Voron 0? Voron 0 corner level script. Or do we have to do it manually? Screws, tilt. Let me figure out. I want to figure out. Screw, tilt, adjust. No, that's not what I'm looking for. I think there's a simple bed screws adjust. Yeah, I think there's a simple script, but it needs a little configuration. You need to give it at least the positions of the screws. Here we go. I think I found something. Let's check out the config file. Is there anything for the screws adjust in here? Bed screws. Here we go. Bed screws adjust. Okay, let's do it. It's already there. So let's do bed screw adjustment. Let's save and restart because we changed the acceleration limits. Okay, so what I want to do is now really fix the do the bed screws adjust G28 out the Benchy, of course. So we're gonna go into each of these corners now and adjust those bed screws so we have a better start. Where's my scraper? Here we go. It's pretty sticky, actually, the filament. I think I pushed it a little too hard in the beginning. Just want to clean this. Can we get this off properly? Hope so. So now let's do the bed screw adjustment. Need the printer come closer to me so I can do this. So bed screw adjustment. We're running this script. Printer should go into. Oh yeah. So great. Okay, so we're gonna adjust the first corner. So we have some leveling distance, same leveling distance, okay. Next. Back left. Where are we now? Okay. I think we're going to do this at least 2 times. Okay, that's, I think what we should do is we should bring down the bed quite a bit, because those screws are really not tensioned very much, so we can bring it up again. Okay, let's start all over. Okay, we need to do the Z, the center offset first. So let's do set and stop calibration. Ah, come on. Okay. Okay, so let's start again. We do the middle first. So there is a little bit of contact, that's good. So let's save that first. Printer is restarting. Now we're doing one more time homing. And then we'll do the corners. Okay, so I will just give it a bit more tension in all of the corners now, just to be sure. So let's see where we are ending up. That's great. Quite close already. So just good enough. This corner, that's too far away. Okay, just enough. That is too close. Okay, next one. Back to the front. Okay. One more time here. Okay. I think we should be good now. Okay, fair enough. Now, a last set offset calibration. Let me abort 28. Okay, so the next thing is really want to push the limits. We will definitely want to print at a higher speed and with higher acceleration values. So let's do this again. Okay. How much of a distance is there still? Not much, hopefully. Are we getting closer? Here we go. Okay, that's just took enough. Okay, so got all of that save config. Okay. Now you wanna set the print speed settings, 250 outer wall, 300 inner wall, 300, 300, 150. Yes. So the standard profile should be fairly fast, I think. Travel 350, I'm probably gonna go 500. Acceleration 1000 in the first layer, top surface 3000, travel 7000. Okay, I guess we want to push it. Then we also do want to disable, we want to tune the retraction a bit down, or at least the number of retracts. Yeah, that's a good question. Can we, what do we want? Retraction length 0.8, probably 0.4 or something. Z-top 0.2, if at all. Do we want Z-top? No, for the Benchy we don't want, right? So let's let's set this to smaller value and disable the Z-top for this print, and let's go. So we want to do timing. Do we want to do timing for this print? I guess so. Okay, is it starting? Yes. Okay, it's doing the heat up. Yeah, the phone maybe wanna fall off. I have a phone stand that would be helpful. Let's use that. Let's put it over here. Here we go. That's good, huh? Nozzle is heating up. So first, I would say more reasonable speed Benchy on this printer. Probably still not perfect, but faster than before. So any moment should start. Any moment. Temperature is almost there. Okay, so homing. We do want some light, I guess. Okay. First layer is so far. Maybe we need to push it a bit closer, but yeah, maybe also not. Let's keep it like that. I think it's good. Okay, I think I have set the auto cooling on. That means we are slowing down when the filament has to cool. Probably have to tune that still, but it should be faster now. It's definitely faster. Oh yes, baby, it's much faster now. That is what we want. That is what we want. We want speed. Don't call me now. And I have no reception here, so it's anyways not working. Even if he would call me. No reception here in the basement. So, at least it looks like it's going to be a little bit faster than before. I think with auto cooling disabled, we could be even faster, right? And then speed Benchy rules, we would be going with higher layers, 0.25. Yeah, different settings. So speed Benchy rules are giving us more freedom. We could reduce the infill a bit. So we're really aiming for a real speed Benchy. I think we should have we should create a speed Benchy profile and then tune that even further. So we could try, I can look up the speed Benchy rules and adapt another profile for that. Benchy rules. So I'm gonna create, I got the 0.25 millimeter speed Benchy rules profile from my V100 anyways. I think we can reuse that. Should actually be possible. But there's also crazy, I mean, we also have other limitations. We should figure out what's the flow rate limits of the material. Probably switch to hyper PLA. Yeah. There's a couple of things that we definitely need to tune here. Speed Benchy rules are, I think we can copy that for the Voron 0. So anything can stay as it is. The only difference here is probably the speed settings are a little crazier. And setup is, of course, setup is disabled, but we also have that disabled. We actually don't have any setup here. What about auto cooling, slowing down for... That's probably also a setting. Maybe we need to turn off that auto cooling at some point. We're clearly slowing down for certain areas. Absolutely. Yeah, the phone. It's an iPhone Max, but I agree. The printer is quite small. So I guess it's not going to be record breaking, but faster than before. We can tune it even further. I guess what we need to do to make it print faster, we definitely need to disable auto cooling. We need probably another filament, and we should raise the extrusion limits. So the flow rate of the material is currently set to a lower value, so it's probably also limiting the slicer in a way to put out faster movements. I'm actually not unhappy with the cooling, to be honest. We seem not to have cooling issues so far, which is interesting because we were printing slower, but the temperature is also a little bit lower now. Maybe it was definitely set to the print temperature was too high for that material. That was definitely not correct. And it's still too much. I guess we can still lower it by 10 degrees or something. So, is the print volume big enough to print a phone case? Oh, my phone just turned off. Why? What are you doing? Why is the phone off? What's going on? What is going on? Why is the phone turning off when the timer is running? Why? There's no reason. No. Anyways. Screensavers. Why? But I want to print faster. I mean, this is not like we need to be under 10 minutes, my friends. We want to be under 10 minutes. We need to push it even further. We need to push it more. We need to be under 10 minutes, honestly. Otherwise, I'm disappointed. So I tend to stop it again. I mean, we can finish this one maybe. I don't know how long it's going to take. What does it say? It's still taking, I don't know, 27 minutes? Can that be? No. That sounds a little bit crazy. 27 minutes from now, 27 minutes for finishing the Benchy? Unbelievable. I can't believe that. So we should be faster, honestly. We should go faster. So I think we should take, do we have Hyper PLA? What's that? Is that Hyper PLA? That's ESUN ePLH high performance. High performance. Okay. What was the settings there? Yeah, save. Yes, okay. ESUN ePLA. What were the? Yeah, 45. I think it makes more sense than to use the more extreme ESUN ePLA HF filament. How long is it gonna take? It's gonna take too long for me. Actually, I wanna be like 14 to 15 minutes is my limit, I'd say. Because the V100, we have under 15 minutes was the goal for the V100 speed Benchy test. So yeah, let's call it. Let's stop this. This is too much. Honestly, I don't like to do this, but we need to be under 15 minutes, honestly, otherwise it's not reasonable. So I would say unload filament. I'm going to unload. Hope you're not homing. So we're unloading the filament and we are loading the Hyper PLA. And we are using the speed Benchy profile from the V100, which should give us at least a reasonable push again. I think we're still too slow. It's still too little. Too little acceleration values. I think we should also push the limits on the machine. I mean, we have 10,000. I think we should go with 20. Honestly, it doesn't really make sense. I mean, we should find out what the limits of the machine are, right? So if we have good bed tension and stuff, can you please unload the filament? Okay. Okay, so great. Okay, now let's go with the ESUN. I think we did not yet enable the filament sensor in the config. At least I didn't see anything that shows me that we actually have a filament sensor. But that doesn't matter for now. What do I want to do it? I mean, we have a filament sensor, we should use it. Do we need a homing for that? I think we should adjust the homing filament load position to something at the edge. Yeah, but anyways. Let's go. So, hyper PLA going in. Let's reset. Where's the reset button? Okay. Great. And what does the slicer say about the speed settings? 13 minutes, 31 seconds. Do we have any machine limit set? I hope not. Machine setup. Motion ability. Okay, that's 500, 500. Okay. Yes. Good. Let's push the printer. What are my speed limits on the printer? Just to double check. Did I set anything? 600, okay. Okay, let's go. One last try. Aiming for 13 minutes for the Benchy. Something around 30 seconds, 13 minutes, 30 seconds, something. I don't know if it's realistic. Homing speed, yeah. I mean, we don't need a Z probe, right? So we can increase the speed. Probably a little bit. It's a bit slow. Let's try. My friends. It's heating up again. How are we doing? Yes, so temperature for the nozzle is coming up. Okay, so you should be ready in a couple of seconds now. And hopefully see the homing happening. My last act for today, 13-minute Benchy hopefully. So we can cut that out for the video, for a separate video. So let's start recording. Separate clip. So my friends, we're starting a first real speed benchy according to the speed benchy rules. We're aiming for something under 14 minutes, hopefully. So let's see if we are successful on the first day of the Voron V0 being operational. I'm really curious. Okay, let's see. Here we go. Is this extruding? Yes. Okay. Okay, this looks way more like it should. I hope we're doing the right thing here. It's still, why is it slowing down so much? Is there still some auto cooling enabled? I don't know. Oh, I guess. Okay, I see. We got some, I think we got some issue here. Okay, that was too much. That was obviously too much. I think we got some, we lost some steps. So, and the printer was jumping around. So we'll probably have to tune down the acceleration a bit. Let's see. Maybe. Okay, so probably have to reduce acceleration values. Try something more conservative, but also wanna see, do we slow down? No. Okay, so we're not supposed to slow down. Fine. Okay, I agree that we have to do this one more time. Okay, let's go with 10,000 millimeters acceleration. 16 minutes. I'm not sure if the belt tension needs to be increased for this. Probably need to do the tuning one more time. It could be that we skipped either we have too much friction at some point, or we need to tune stuff. Let's see. Okay, doing this again with lower values. Okay, so this is my hopefully last attempt to print a speed Benchy tonight. If we're not lucky, I'm going to call it a day and we're gonna try tomorrow. Maybe some tuning will do. So let's do the first one now. Let's see what we get. If it still hits the wall, then I think we're still having too much aggressive values. Is it too much? Or is it working? I'm wondering. Yeah, I think it's probably at the limits of the hot end, so flow limit could be a problem. Yeah, but we're still printing. It's not the most beautiful. It's not going to be the most beautiful Benchy, obviously, because we have some under extrusion problems. Maybe we need to push the temperature, but it's already 230. At least we're not going to, we don't have these step loss problems. But I think we have clearly an under extrusion issue. Sure if we, should we push the temperature up a bit? Let's see. That doesn't help too much, I guess. Does it? Okay, so it seems that we're going to make it through this Benchy print. With some issues, some under extrusion problems, but we're still gonna get something that's recognizable as a Benchy. That's definitely possible. Not the most beautiful print though. Good. Good and Carmen. See you next time. Next time. I'm gonna upload the Benchy print. When we're successful, I'm gonna upload it as a separate video, so you can watch that tomorrow. Good night. Okay, so we're gonna finish this print. We're also gonna call it the night. It's already 1 o'clock at night in Germany. But we've got a working printer, we got a Benchy printing fast. Not the most beautiful result, but still recognizable as a Benchy. So 6 minutes, 50 seconds in. Yeah, we're doing good. What does the slicer say? Still 8 minutes, 40 seconds to go. Maybe it's gonna be a little bit faster. Let's see. $7 p.m. Eastern Standard Time. Okay, also not too late. Great, great, great. To be honest, guys, I'm happy that we made it so far through this build. I'm happy that we didn't have any major hiccups so far. I mean, a couple of minor topics, but nothing serious, surprisingly. That also speaks for the quality of the kit from LDO. So about that, I'm actually really happy. All of the parts are high quality parts. And the only thing that could be better is the LDO manual, because we have to jump back and forth so many times between the original and then the LDO version, and then another sub-guide, and here another sub-guide for a specific topic. So I think we had at least 5 different guides open, jumping back and forth for this build. Probably one of the most challenging 3D printer builds that I've did so far. And we're still not fully done, right? We still have to do the side panels, the front door, and the top head, and that's probably a couple more hours to go. Not that interesting in a way anymore, probably, but finishing the complete build is definitely my goal. The other thing that we still need to do is the front display, because that's definitely a nice add-on. Maybe for the housing, some LED lights, and eventually I'm thinking of carbonite filter system. Phone screen is off again. Oh my goodness. Why are you doing this to me? Okay. So 10 minutes in. Is it realistic that we stay under 15 minutes? Probably not. I think we still have a Could be very close to 15. I'm not sure. Slicer says still 4 minutes 50 seconds to go. Let's see. But under 15 is already something that's a good achievement for today. Since we're just tuning the settings and finding the right temperatures and such stuff to do, it's probably not too bad. Good thing is we don't have any stringing anymore. We had stringing, probably was the material also a problem. The extruder, by the way, seems to work pretty well. Anyways, all of the parts seem to work super nicely. Electronics, I can't complain. Actually, there's nothing to complain here. Finished in 3 minutes, 30 seconds. Let's see. Round about 15 minutes, I would say. Probably not under 15 minutes. We had to be under 15 minutes for the official V100 serial number application. I don't know how the rules are for Voron. If you want to request a serial number from Voron, if you need to be under 15 minutes. So if that doesn't work yet, yeah, I see it. For Furious isn't bad now. So I'm not sure if we can stay under 15. Still have 3 minutes to go. I think we're gonna go for 16 minutes with this. It's definitely Do I have to enable captions myself? Is this something that... Maybe we should have a captions... yeah, we should have captions for the stream. That's actually not a bad idea. Is this something that I can do from Twitch? I'm not sure. Porphyrius, you should... Speed factor is on 100%, but I had cranked up the settings quite a lot. Okay, so we have 14 minutes, 20 seconds. Oh my goodness, I don't think we're not gonna make it on the 15. We still had to push it. We need to find better print settings. Question is, can we accelerate faster or can we just increase the print speed? It's a very good question. What are the limits here? Yeah, we're still doing the roof. That's gonna slow us down now. Okay, we're over 15 minutes. Let's see how much we're actually going to be over time. Definitely want to be under 15 minutes with the final Benchy. If we do a serial number application, I need to check How does it look like? Okay, so we need to, do we need to be under a certain time? Okay, we need to be ready to stop the timer. Okay, first complete Benchy done in 16 minutes 23 seconds, which is, it's okay. However, not the most beautiful Benchy ever. Let's say these were the lower areas. I increased the temperature by 10 degrees, somewhat around here, and it improved. So I guess there was an extrusion issue because of the print temperature being too low. Then it got much better. Bed temperature is probably too high. We probably reduce it because this is sticking like crazy. I think we can go down to 50 degrees or something, or 55. So we have less of an elephant foot here. But yeah, nevertheless, it's a Benchy, and we can probably push it to be under 15 minutes. My personal goal, because we had print time under 15 minutes on the V100 already, and we should be able to do this with the Voron, if I'm honest. Thank you for watching. We're gonna see each other next time here on the stream or in another video on this channel. And until then, I wish you a good rest of the day, rest of the week. Enjoy your time, enjoy printing. Bye-bye.